Hi, my name is Shaun Wallace. I'm a PhD candidate at Brown University advised by Jeff Huang. This work began during a research internship at Adobe, where I was advised by Zoya Bylinskii. I'm grateful to my many co-authors who came together to study fonts and remote readability. We set out to study whether the average adult reader can see improvements in reading performance simply by changing the text format. We began by looking at what prior research says about font choices, font size, and the relationship to users' reading speed and font preferences. Each row in the table shows if there is a relationship between the two variables in the header per study. For example, in the far right column, we can see there's a relationship between font size and font preference. While in the first column, we can see prior research shows font does affect speed, but it's complicated. It is complicated because font choices and the devices we read with have evolved over the past 2 decades. Most importantly, when comparing two fonts rendered at the same size, say 16 pixels, they may not necessarily be the same visual size. Previous research and interviews with typographers show us that font size needs to be controlled. We found in preliminary studies when all fonts were 16 pixels that size predicts preference. So for example, many fonts are designed to have a larger height for a lowercase x than others. This is a lowercase x in Times at 16 pixels. And here's a lowercase x in Montserrat, also at 16 pixels. When these are overlaid, the lowercase x in Montserrat is clearly larger. However, we can decrease the size of Montserrat so its lowercase x has the same size as Times. We used Times as our control font and computed new pixel values for all 16 fonts in our study based upon 3 normalization methods: lowercase x height, the average character width, and the average character height. We recruited paid crowd workers to compare the size of fonts rendered using these 3 methods in addition to applying normalization, and voted on which method was most similar in size to Times, resulting in new normalized pixel values to render each font at. Here's a list of the 16 fonts we used in our final study with the normalized text size to the right. We selected these fonts for their common usage across multiple different mediums. We developed several open source tools and web applications to run large remote studies to study Interlude Reading, a reading mode focusing on typical reading tasks such as reading forum posts or blogs. To evaluate these tools and fonts, we've run several smart large-scale studies with paid crowd workers. Our focus is to understand if some fonts are preferred and effective across a population, or are there large individual differences? Can one font increase reading speed for all, or does everyone have a different font that helps them read faster? Our studies feature participants that mirror the general digital reading population. While participants are very comfortable reading English, they represent many different countries and languages. So, how do we find someone's fastest font? Maybe people can select their fastest fonts based on their preferences. To determine someone's preference, we develop a web-based toggle test that should be familiar to anyone who's ever done an eye exam. During the font preference toggle test, users will see the same text rendered in 2 different fonts, and they can toggle between the 2. And then they select the font they preferred the most. All of our interfaces are developed with an e-reader aesthetic, and they are designed to be consistent in presentation across all devices. So how do we measure reading speed? We split a passage into 2 screens so we can get 2 different measurements. We capture words per minute by starting a timer when the reader first sees the screen. And in the background, we're also tracking mouse movements on desktop devices and motion controls on mobile devices. As the reader proceeds through the 2 screens, we capture a reading speed measurement each time. The study designed for our large remote study features preference and reading speed tests to help determine an individual's best and worst fonts. In this study, all participants read in Times and Noto Sans because those fonts performed well in our preliminary work. For our results, we only used reading speed measurements between 100 and 650 words per minute to ensure readers are not skimming or memorizing content. We found that participants' reading speeds increased by 35% when comparing their best and worst fonts. So let's break this finding down further. Our readers who experienced the largest gains in reading speed could read a 700-word article over 1 minute faster. Imagine you were reading something that normally took you an hour to read. With the right font, you could get back 20 minutes of your time. So we saw the right font can increase reading speed. Wouldn't it be great if users' preference for a font was also predictive of their reading speed? Our findings show that participants do not know what is best for them. 73% of participants believe their most preferred font would also be their most effective to read in. That only happened at chance. However, amongst our reading speed preferences, a post-survey found that participants described their preferred font as bold and modern with natural character spacing. While many older participants wanted a font that decreased eye strain, younger participants preferred fonts with tighter character spacing, believing this would help them read faster. We found that certain fonts predictably affect reading speed, making it possible to make some general recommendations for people over the age of 35. For instance, E.B. Garamond and Montserrat were particularly fast fonts, while Avant-Garde and Open Sans were slow. However, looking across the whole population, fonts do not affect people in the same way. A font that is effective for one person is not necessarily effective for another. It can be deceiving to rely on averages to understand a font's effect on reading speed. For example, E.B. Garamond was the fastest on average at 312 words per minute. However, individual participants only read faster in it 48% of the time, compared to the other fonts they read in. In contrast, Open Sans was the slowest font on average, while individual participants read faster in it 51% of the time. So maybe certain fonts might help readers with different abilities. Now, when looking at an individual's fastest font, it was at random if a participant read fastest in their most preferred font, Times, or Noto Sans. Each black line in this figure represents the distance between a single user's slowest and fastest fonts. These lines are ordered by average reading speed per user. Most importantly, while there was no one font that worked for everyone, participants could experience large gains in reading speed with the right font. We found that for 94% of our participants, they experienced medium to large gains in reading speed when comparing their fastest and slowest fonts. This figure shows the reading speed measurements for our fastest readers. It shows the potential that font alone can have on reading speed. Hence, being able to quickly and accurately find someone's optimal font can be massively beneficial in their daily lives. The most effective font for reading speed varies across participants. Fonts with different attributes and anatomies are effective for different people. Hence the need for personalized reading experiences. While a participant's most preferred font was not always their fastest, our recent work shows that if you generally prefer a font, you will also most likely read faster with it. So if preference in a font will not hurt your reading speed, feel free to read in the fonts you prefer. You might read faster because of it. We found that different fonts work best for different people. And also changing font alone produces the biggest gains in reading speed compared to design manipulations such as changing character spacing. In all of our studies, one thing remains constant. Different settings work for different people. Hence the need to study personalized reading. To help engineer future personalized reading experiences, we've developed a collaborative community of organizations to create the Virtual Readability Lab, or as we call it, the VRL. In the VRL, we help rapidly prototype and run new personalized readability experiments. Through this joint effort, we are creating the largest data set of reading studies ever, and these results will help individuals find their fastest fonts and inform future research. Thank you very much.